In the original relation that given in the question, the total cost, A was my fixed cost and my variable cost for every unit was B. So this is my lunch cost or this is my bus hiring cost, right, in our analogy. When I change it to cost per unit, if you look at this, A, the fixed cost, so I am rewriting this with fixed cost divided by the number of units. So this plus the variable cost, the lunch cost. Whoever comes will have to pay for his lunch entirely. No one is going to share that. However, the bus cost, the fixed cost will be shared amongst all the people equally, right? So I can change the total cost per unit into share of fixed cost plus the variable cost, right? And this is what I'm going to do to solve it directly. So we are going to divide this 270 into certain share of fixed cost plus a variable cost. 180 I will divide it into share of fixed cost plus a variable cost, right? Now what I know is the share of fixed cost, this varies inversely with x. So if the number of units are 10 and 40, that is 1:4, the share of fixed cost has to be in the ratio 4:1. If 4 times as many people start going on the picnic, the bus cost will be divided in 4 times the number of people. So each one of us will have to pay 1/4 now as compared to earlier. So this ratio is going to be 4:1. This has to be paid entirely by each one of us. This is same. This is going to be same. There's no difference here. Our lunch cost we would have to pay. So the difference of this is arising only out over here. And this is that small question. Let me just write it in a separate way. This question boils down to as simple as two numbers are in the ratio 4:1 and the difference of the in the numbers is nothing but 90. So the difference is 90. So this is a ratio and this is the actual value. So we come down to the basic question that we have. Also the difference here is 3. 3 is multiplied 30 times. So 4 into 30, 120, 1 into 30, 30. So the share of fixed cost is 120 and 30. And this is why the cost is reducing by 90. Let's see, if the share of fixed cost is 120, why am I paying 270? I am paying 270, that is an extra 150. That would have been my lunch cost. Oh, so if there is a 40th person comes, would he still pay 150? Yes, everyone will. And is 150 plus 30, 180? Hope you got this. So how do I come to my answer? Oh, so the cost per head is going to be share of fixed cost plus a variable cost. This variable cost will remain 150, will not change. How do I find my share of fixed cost? What is the ratio out over here? 2:5. 4 and 10, 2:5. So this will be 5:2. 5 parts is 630, 6 times. 2 parts will be 6 2s are 12, 150 plus 12, 162 is my answer, right? I find students taking some time to comprehend this or even use it. So I would advise replay it, run it again. The essence is just two numbers in the ratio 1 and 4 or rather 4 and 1 with a difference of 90. Once you get that hang, then things will flow further ahead, right? So CAT does check on this part of variations and decently regularly, right? So in fact, some tougher questions are also asked on this concept. So we'll do one question out over here, very similar to a CAT question. I've just increased the difficulty a little marginally. The example reads as, reduction in speed of a train varies directly with square of the number of bogies. So this time we need not take the number of bogies, but square of it we'll have to take. With 14 bogies, the speed is 120 kilometers per hour. With 16 bogies, the speed drops to 100 kilometers per hour. The question is, find the speed when 20 bogies are attached. So if I capture the data again, remember we are finding the number of bogies squared. So rather than use number of bogies, I'll use the square itself directly. So if the number of bogies are 14, that is the square of it is 196. The speed is 120. With 16 bogies, that is n square is going to be 256. With 256, the speed drops to 100. And the question is asking with 20 bogies. So if n is 20, n square is going to be 400. What is the speed? Now it's given to us directly that the reduction in speed varies directly with square of bogies. So the reduction in speed, so let me say the speed reduced by 20 when the number of bogies square increased by 196, so this is 60. An increase in n square of 60 causes a decrease of 20. I again point out the difference. This is a decrease. However, here it's given to me that it varies directly, right? So I can still continue in the same process. So from 156 to 400, which is an increase of 144. 60 has become 1/3, that is 20. So 144 will also become 1/3. 1/3 of this is 3 4s are 12, 48. A decrease of 48. Or else you could look at it as a ratio this way and find the same ratio out over here. You'd get the same answer. A reduction of 48 from 100 is that the speed is 52 kilometers per hour, and this answer is correct. What I want to point out in this question is, we had just seen an earlier case where an increase was causing a decrease in cost per head, and we said we could not use this approach, right? Then how is it that we are using it here? Hence I say you sometimes need to be very thorough with the topic or the theory that we are doing. If you notice here, it's saying the reduction in speed. So the speed has reduced when there are some number of bogies. So the reduction, is speed equal to some constant, let's say a times the number of square of the number of bogies? Is it given as a speed? Not really. It is a reduction in speed. So where do I measure this reduction? Let's forget there's some other data. With 14 bogies, the speed was 120. Has the speed become 120 after reducing from some place? From where? Where am I going to measure the reduction from? Obviously, it has to be with when there are no bogies attached. So remember, speed is not directly proportional to square of number of bogies. The reduction in speed, and the reduction in speed could be said as from some benchmark, from some constant. Since I've used A out over here, I'm using B. B minus the speed. B minus the speed, current speed. This is the reduction in speed is directly proportional to square of the bogies. If I rearrange this relation to write it in terms of speed, speed is equal to B minus AN square. So this is of the type y is equal to a constant minus a constant times x, right? So the relation still remains the same. Then how is an increase caused by a decrease? Because the coefficient attached, the constant attached with x now is negative. So as x increases, the minus ax will also increase, and this is subtracted, and hence I'll get a lesser value. Though mathematically the relation is that of partly fixed and partly varies directly with the x out over here, right? And hence this process works even though there's an increase accompanied with a decrease. So this example highlights that we cannot just mechanically look at increase or decrease, right? And when we started this topic, I said the relation of direct variation and inverse variation is, colloquially speaking, you might say an increase causes an increase, right? But that's not the entire truth. The entire truth is what mathematical relation do you have? Is the ratio y by x constant, is y is equal to kx, or is y is equal to k by x? Here we do not have any divided by x, right? So this stays as a direct relation as such, and so I can use this funda. Cat has gone a step further, and there was one more interesting question based upon this funda. I've already done a video on that sometimes long back, so the next one I'll just put up that video without any theory, but make sure you go through that. So this is where we end with the relations of this type. Next we will look at joint proportion.